Hello everyone, my name is Rujan and in this video we are going to see a production ready 3-tier architecture which is deployed on Azure using Terraform. It is designed for scalability, security and as well as high availability. So as you can see in the picture, there are 3 tier. First, web tier, which we are going to say as a front end, app tier as a backend, and DB tier obviously for database. Whenever a user is going to access the application via application gateway, we are applying a web application firewall on it, which securely routes the traffic to virtual machine scale set. In that virtual machine scale set, Docker containers are running across multiple availability zones. So, talking about backend, an internal load balancer distributes the traffic to the backend services, which is virtual machine skill set, hosted in a private subnet, ensuring no direct internet exposure. So, only only first tier is exposed to the internet. The backend tier and DB tier are not exposed to the internet. Now, talking about DB tier, in this tier, we are going to use Azure PostgreSQL Flexible Server, which is also known as a Flexi Server, because it is very flexible to use. And here, there are two instances. First is a primary, second is a read replica. Set up for high availability and read scalability, accessible only via private endpoints, which is DNS. Okay, so talking about security aspect of this project, we have deployed Bastion servers to access the VM using SSH port 22, as well as NAT gateway for control outbound internet access. So we need to deploy NAT gateway because on the backend side we need to pull Docker images. For that we require internet. So instead of normally assigning public IP, which is a very bad practice, so we have deployed a NAT gateway which will give us a control outbound internet access, as well as there are key vault for secret management, and we are going to pull all the images using Docker registry, or we can say Docker hub. So yeah, this is the architecture, and all these components which we are seeing in the screen are going to be inside one resource group, and that resource group we are going to call as a production resource group, or we can say prod RG. So one more thing I need to discuss here. We are seeing here Docker containers, right? In that Docker continuation, there is a one SIM Lite application which we are going to run. So I quickly let me just share my screen, which I am already sharing. By the way, I'm just saying. Let me share the different architecture here. So in Lite architecture, uh, in this architecture, three components are there: agent, backend, and dashboard. So yeah, just like real life SIM, it is going to collect some logs. It will segregate that logs in multiple sections, like for example authentication logs, error logs, or file deletion or installation logs, like that. It is going to segregate all the logs and it will show us on the dashboard. Okay, like that only. So let's just jump to our code and let's see what is happening there. Okay, so let's focus on the code right now. So as you can see, this is our main.tf, output.tf, provider.tf. Provider, we are just going to mention HashiCorp version is 4.6, and in main.tf, we are going to start the code using Azure resource group. So basically, first thing we need to do to deploy a resource group. Inside that resource group, we are going to deploy all the components. So here we are going to use module, because if we use module now, the specific chunk of code now we can use multiple times. So here are some models like database, DNS, key vault, network, and virtual machine. So as you can see here, we are using network. So inside network, let's just open me the module network. Okay, here we have mentioned local.tf. So so basically these are all network security groups. So because of this, the communication between Bastion node and primary virtual machine shell set or firewall network security group, all it is defined in single local.tf. So we are going to use dynamic loop in network. As you can see, let me check the code here. Wait a second. See, here we are going to use dynamic, and this code will run again and again and again and create all the network security groups which are required for this project. Okay, so let me check this. Okay, this is for gateway manager inbound. Here, this is for load balancer inbound. This is for Bastion. Like that, we are going to allow all the necessary network security group we need to mention here. Okay, remaining just like we are going to define the public subnet and assign the public IP, private subnet, database. We are going to provide three separate subnet. First for front end, second for backend. For backend, we are going to provide private subnet, and also for the database, it is a private subnet. Here we are going to mention delegation so that it will successfully reach the endpoint without any issue. These are the public IP we are going to define. So basically, in the network module, everything related network, we have combined it and put it together. And then let me go back to our main code. Then there is a key vault. So key vault is being used to store all the secrets like database secrets and our Docker Hub secrets. Yes, as you can see, we have created the key vault, and inside that we are going to mention all the database secret. For example, database host name, database username. So instead of passing the username and password manually, we are going to pass it via key vault. So it won't be exposed anywhere. Okay. Again, we are going to pass data db port also, ssl mode also. Ssl mode we are going to mention as a required here. Okay, then database sorry, docker hub username, docker hub password. So here we are going to mention docker hub password, then database. So here this module will help us to deploy the database. As you can see, we are going to deploy two database. One is primary, we have mentioned here, primary, and there will be another database, replica. Here you can see here, replica. So we are going to define in database. Let me come back again to main, and there is a one DNS so that database can easily communicate with Microsoft endpoint services. Then again, there is a separate module for front end as well as a separate module for backend. And these are the database communication which is required to communicate with backend. Okay, let me check for front end also. Okay, front end. Okay, these two are for front end and backend. So I have commented out the monitoring module. Next time we will in the next video I will also add monitoring module also to monitor all the resources. Okay, so this is our all the infrastructure, and this is our environment where we have defined the value of variables. So as you can see, in each module database, DNS, you can see there is output module, sorry, there is output file and there is a variable file. In DNS also there is a output file and variable file. So all that variable files now we need to define the value for it. So we have defined it separate tfvar files. So in just case, if we want to expand this code, we can expand by just creating a new file here, and we can mention it non-prod tfs, and we can pass that values into the environment. And we did not do any changes in infra, just we need to change the tfvar files, and automatically we will get our separate environment without changing any code. Okay, so this is our code. This is the dot ssh key which we need to pass when we want to connect to the primary front end VMSs or backend VMSs. So this is our front end, backend, and agent. We have also created a Docker file, and we are going to the Docker images from the Docker Hub and use it here to run our application. So let me just quickly start our application. CD. Let me go into the folder. Okay, we are into the folder. Terraform, not destroy. We need create right now. Init first. Okay, we have duplicate variable declaration. Let me just check. I think it's key vault where it is. Modules, key vault, main.io. In 33. Okay, Azure role assessment, backend secret user, front end secret user. This is for backend, this is for front end. This is the variable we have defined, but I don't think so. We have mentioned somewhere. But they are saying a variable named backend identity principal TF was already declared at. Okay, okay, okay. Just need to copy it, and there is a variable file here. We need to mention it here. Already mentioned it is. So already variable file was mentioned. That's why this was the error. Let me just clear. Sorry. Let me just clear it. Okay. I think that might solve the issue. Yes. The TF now it is installing the HashiCorp Azure RM version. Sorry. Let me go back to the code. Okay, fine. Okay. So let me run Terraform plan. So we are inputting our TFVAR files so that the Terraform plan will work according to our local values which we have defined in TFVARs. Okay, so Terraform plan is now running. It will pass all the local, all the TFR variables inside our Terraform infrastructure, and it will provide us the output like what we are going to deploy. Okay, so as you can see, it is successfully run without any error. Okay, 60 resource we are going to deploy. We cannot say resource. Let's say component we are going to deploy, zero change and zero destroy. Okay, so as you can see, all the network security group, everything will be deployed. Okay, so let me just hit Terraform apply to deploy all the mentioned 60 components auto approve, and obviously I'm going to stop this video because it will take nearly 30 minutes to deploy, but I will meet you again. So yeah, all the resources has been deployed. As you can see, these all are the output variable values. So our prod application name is prod app gateway. This is our internal IP, private internal LB IP. Then load balancer. Then we have hide our private SSH key. Then IP. This is our front end URL. So yeah, so all 59 resources has been added. One resources was already added. That's why instead of 60, it is added 59 resources. So yeah, just let me open our front end IP and URL. Open. It's taking some time. Let me just enlarge it. Okay, it is saying bad gateway. So let me just open our container. What's happening in the container? Let's see. So all the resources has been successfully added. So this is our backend, this is our front end. So let me just open front end one of the instance. Okay, vmss underscore one. Let me connect with it we using Bastion server. That's why we are deployed the Bastion server to securely log in into our virtual machine skill set. Local key, our username is admin user, and we need to manually enter our backend and front end. So these backend and front end is, I think these are the old one. We need to take it again manually using SSH private key. It is output backend SSH key into backend.pm. Similarly, we have done for the backend. We want for front end. Just we will remove this and enter front end. Enter. So yeah, it's showing that gateway. Yeah, let me click front end. Open. Connect. So it is connecting to our virtual machine skill set Linux OS. Connected. Sudo dash I docker. Yes. So none of the container is running right now. Let's see why they are not running. Cat slash var slash slash content. Array. Sorry. Yeah. So as you can see, we got here forbidden by role-based access controller. So basically, which user we were using to access this virtual machine skill set, in that script .sh script, I will show you that script. Because of that, the container was not being deployed. So in virtual machine, there are two scripts: front end and back end. So in this front end container, as you can see, there are some, for example, yeah. So this is the login file which we use to actually know what exactly is happening. Then ensure we run all the commands using root. These are the variables, and these are the commands to run when the VMSS is in bootable state. And we are installing Docker here. Then Azure CLI we are installing, then login into the Docker using the credential. But that credential which we are using, that are forbidden by role-based access control. So let me just fix that. Okay, so we have fixed the issue. Let me just tell you what was the exact issue. See, here also we were getting forbidden by role-based access controller RBAC. So basically, what was happening? Our app ID, that is client ID, tenant ID, and client password, was different. That's why role-based access controller was denying our request. That's why we have inputted the correct one and tried to pull our DB username, and it is correctly has been pulled. So issue has been resolved. But now the main problem is we need to again rerun our script in our virtual machine. That's why we need to delete the instance and recreate again, or we can just, there is another way, but for now we are using this only for clean start. Apply. So again, I'm going to pause this video because this again both the front end and back end deployment will take 10 to 15 minutes. Okay, so finally we will run our application. So I'm just going to put my public IP and along with its running port 8501, and our Streamlit app is running. Yeah, so as you can see, SIEM dashboard is visible now. Total for now 4 logs we have gathered. Which of them? 3 we have identified as authentication log, 0 for installation, 0 for error, and network. Okay, so the SIEM app will divide all the logs within 4 categories. So total log will be 4. and these are remaining are like segregation. And as well as we will get to see this is the container IP, container ID, and this is the private IP of that virtual machine skill set, as well as what is the CPU utilization, RAM, total disk storage, everything will be mentioned, and this is the live logs. So still we are getting 4 logs. Let me refresh it. Yeah. So we need to, I think, manually refresh for the logs. Let me check again. Yeah. So yeah, this is our application SIM dashboard. As you can see, without refresh, it is working, but it is taking some time to gather all the logs. It will first log send to backend. Backend will segregate along with the 4 components like authentication, install, error, network, and then that backend will send it to the DB. DB will store in the table, and the dashboard will pull that table and show it to us like that. Now CPU utilization is also increased to 1%. We can segregate the logs here also. Like for example, if you want to check only file authentication or authentication log, we can see here password fail. Okay, yeah. So yeah, let's check one more time. These are all the logs we are getting. CPU utilization again changed to 0%. So yeah, without refresh, it is actually working. It is continuously running and pulling the live data. Okay, so just quickly we will do the recap of the entire project. So again, this is the architecture. A user will log into our application gateway, and we have implemented the application firewall here. The public IP is assigned to it. We have separate network security group assigned to it, as well as we have Bastion server to log in into the virtual machine skill set. Again, we have 3 different layer: web tier, application tier, DB tier, and each has different subnet and network security group also. And in the web tier, we have assigned public subnet, and remaining are private subnet. So again, what we can see here, this is the public IP assigned to Azure Net Gateway, so that our application tier can also download the images from Docker Hub. And let me show you the architecture of our SIM Lite also. So what's happening in the SIM Lite application? It is running 3 containers basically: front end, back end, and agent. Agent is running on each and every instance that will be created on virtual machine skill set, that will collect all the logs which are stored in syslog, authentication logs, and maybe file system logs. That will be shared to backend. Backend will be segregate all the logs in different categories like authentication logs, installation log, error logs, network logs, and that will be stored in DB. And that DB dashboard will fetch that data from the DB and will show it to our screen live. Yeah, so this is our project. Okay, bye. Hello everyone, my name is Rujan, and in this video we are going to see a production ready 3-tier architecture which is deployed on Azure using Terraform. It is designed for scalability, security, and as well as high availability. So as you can see in the picture, there are 3 tier. First, web tier, which we are going to say as a front end, app tier as a back end, and DB tier obviously for database. Whenever a user is going to access the application via application gateway, we are applying a web application firewall on it, which securely routes the traffic to virtual machine skill set. In that virtual machine skill set, Docker containers are running across multiple availability zones. So talking about backend, An internal load balancer distributes the traffic to the backend services, which is virtual machine skill set, hosted in a private subnet, ensuring no direct internal internet exposure. So only only first tier is exposed to the internet. The backend tier and DB tier are not exposed to the internet. Now, talking about DB tier, in this tier, we are going to use Azure PostgreSQL Flexible Server, which is also known as a Flexi Server, because it is very flexible to use. And here, there are two instances. First is a primary, second is a read replica. Set up for high availability and read scalability, accessible only via private endpoints, which is DNS. Okay, so talking about security aspect of this project, we have deployed Bastion servers to access the VM using SSH port 22, as well as NAT gateway for control outbound internet access. So we need to deploy NAT gateway because on the backend side we need to pull Docker images. For that we require internet. So instead of normally assigning public IP, which is a very bad practice, so we have deployed a NAT gateway which will give us a control outbound internet access, as well as there are key vault for secret management, and we are going to pull all the images using Docker registry, or we can say Docker Hub.